Hello, students. We are looking at Chapter 7 review. I had a couple of these come up. Let me zoom in a little bit here. And so I'm going to tackle those. So Chapter 7 review, we're going to number 10F. The question was, write in scientific notation without using a calculator. Got it. So, oops. I've got my little tablet here and I did not plug it in. That is not going to work well. Doop, 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 doop. All right, here we go. So let's bring this and let me get a little bit of white space here. All right, so we've got this one, which is number 10F. The question is, write without using a calculator. Now let's give this one a shot, see how we can do it. So first off, if I don't want to use a calculator, and we'll do scientific notation, but really the idea here is you can think of writing this in decimal form as well. That would be just fine. So I've got 5 to the 9th, which means I got 9 5s on the bottom, all multiplied together. I need at least 9 2s to pair up and make the 10s. So what I could do is make these as 10s. So this becomes 3 over 5 to the 9th, and then bring in my 2s. I need a 2 to the 9th, and I need a 2 to the 9th. And that means down here I have 10 to the 9th in the denominator. And up here in the numerator, I have 3 times 2 to the 9th. Now that seems daunting, right? 2 to the 9th. But just remember, 2 to the 9th, what does it mean? It means however you choose. 2, 2 times 2 times 2 times 2 times 2, 9 times. Group it however you'd like. You could group it as 2 times 2, right? That's 2 squared. You could do that 4 times and have a 2 left over. So 2 times 2 is 4. 4 to the 4th power. You could do it that way. You could say, hold on, let me do it 2 cubed and do that 3 times. Okay, that's fine. That's 2 to the 9th. So 2 cubed is 8, and 8 cubed, then you could calculate that. That's up to you. What else do we want to do? 2 to the 4th. 2 to the 4th, that would happen twice and leave 1 2 left over. That's up to you. So any of these that you want to do, you can. If you really wanted to, you could do 2 times 2 times 2 times 2, 9 times just by hand. I wouldn't recommend that. It's so much shorter to kind of make it a little bit easier for yourself. So maybe I'll do this middle one. So I would say that's 2 cubed, which is 8. I need to do it to the 3rd power, which is 8 times 8 times 8. This right here is 64. And times 8 is 2, 3, 48, so it looks like 512. So what I have right here is 512, but I have another 3 sitting in front, so I multiply that by 3, 6, 3, and 15. So I end up with 1536. And what does that mean? Times 10 to the 9th, right? So what I have is 1536 times 10 to the negative 9. So that means I would be moving the decimal to make this number much smaller. But I just need to move it a little bit because I want to write this as 1.536 times 10 to some power. So what I'm doing right now is I'm going to move the decimal this way, 1, 2, 3. That means I made my number smaller. I need to make my exponent bigger. And I do bigger by 3, so my answer turns out to be 10 to the negative 6. That is how you can do it. Well, let's check over here and make sure. Nothing more fun than making a video and I did some part of it incorrectly, right? Let's go to Desmos and see. Desmos.com. We'll do a little graphing calculator. And when I just erase the pieces over here real quick. And let's see how we do. So we have what? 3 divided by 5 to the 9th. Oh, I did 6 to the 9th. Whoops. Whew. Boop, 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 boop. 5 to the 9th power. Okay, there it is. So 1536. And if I count over 3 decimal places, that would be 6. And that's your 10 to the minus 6. So there you go. That's how you can do it. And again, the way, if you're doing scientific notation, and you end up, let me jump to just a blank screen real quick. So if you're doing scientific notation and you're having to rewrite something, like let's just say it's 325 times 10 to the 11th power. Scientific notation means the number in front has to be between 1 and 10. It can't be 10. So that means you're going to want to put the decimal place right here. So that means I need to move it this way to make that happen, which means I'm making the number smaller. But since I'm multiplying, in order to compensate, I need to make the exponent bigger. So this would be 3.25 times 10 to the 13th power. So let's go the other direction, right? What if it was 0.00016 times 10 to the 12th power? Well, now what's happening? Now I'm going to make my decimal go this direction in order to get the 1.6 that I need. And that's 1, 2, 3, 4 places I moved. I made the number bigger. My exponent better be smaller. So I get times 10 to the 8. That's the kind of the nice quick way to do it with scientific notation. Now, if you'd like, you could say, well, wait a minute. How could I do it in a longer way? Well, what you could do is say 325. Oops, hold that. Let me hit pause for a moment. So take 325 and rewrite that as 3.25 times 10 squared, because really that's what it is. It's 3 groups of 100 and then some other stuff. So really that's all you're doing is you rewrite it this way. And then if you wanted to, you could say 3.25, oops, 325 times 10 to the 11th is the same thing as 3.25 times 10 squared. That's the first portion, times 10 to the 11th. Again, all I did is rewrite that number there. And then I use the associative property. Like I said, this is the longer way. 3.25 times 10 squared times 10 to the 11th. And then that becomes 3.25 times 10 to the 13th. So yes, I have done it this way, and some of my teachers required me to show all my steps. Me personally, now that I'm out in the real world, if I need to convert things quickly, I think to myself, if I'm multiplying and I make one bigger, I make the other one smaller. Okay. And that would be like this. If I had a number like 3,000 and I was multiplying by 0.0148, then I really could move the decimal place here and get the number 3, moved it 3 places and moved the decimal place here and get times 14.8. And I got to tell you, the second one looks easier for me to do. This is nothing more than equal products. If you just when you double one, you got to take half of the other one because it has to balance. Okay, let's do one with negative exponents. So let's just say we had a negative 3.164 times 10 to the negative 105. I'm making numbers up. Okay, so notice in order to be in scientific notation, the absolute value needs to be between 1 and 10. So I say this is the same as negative 3.164 times 10 to what power? Notice my value made the number's value smaller. The exponent needs to get bigger. And this is tough for some of you. You want to write a bigger number than 105, but it's negative 105. And bigger numbers are that direction. So I move it 3 places and I get negative 102. Because negative 102 is actually bigger than negative 105. Now let's just say we had 0.000041 times 10 to the negative 106 power. Then how far did I move? Let's see here. 1, 2, 3, 4, 5. So I get 4.1, which is 5 places. And now I made the number bigger here. 4.1 is way bigger than what I started with. I need to make this one smaller by 5. So I get negative 111. Okay. Scientific notation. One of our bestest friends. All right, let's jump back to the other slide. Let's go. Okay, what's the next question we've got, students? 14, number 14. In Norway, let's pay the highest price for this. Average price was this. Same here price in Saudi Arabia with this. 91 cents a gallon. Dang! What is the percent decrease of the cost from Norway to Saudi Arabia? All right, from Norway to Saudi Arabia. Well, here we go. So when you're doing these problems, always think about what am I starting with? That is your base. So Let's go here. I'll just put some of these right up here. And what do we want to start with here? Start with Norway. So Norway is my base. What is the percent decrease? So I'm going to start by showing you my, I don't know, Fallstrom's freaking fast method, the triple F. So what I do is I always start, my base is Norway because it says from Norway. So it's starting with Norway. Norway is $7.08. Then it says Saudi Arabia. So I'm ending up, it's Saudi Arabia, which is 0.91. When I divide this, that's why we did that worksheet in class. If you divide this, you're going to get a particular number. Let's see what number we end up with. Grab my calculator and I get 0.91 divided by 7.08. And I get this number right here. 0.12853 da 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 da. Okay. So now if I want to write that as a percent, because that might help, I could write this as, don't put a 0, 12.85%. I'm rounding to 2 decimal places here. Okay. All right, so there it is, 12.85%. Well, what does this mean? This is where that sheet comes in handy. This is 12.85% of Norway. Norway is Saudi Arabia. And if you want to check it, look at this fraction. You'd multiply the other side. 7.08 times 0.128 gives you 0.91. So 12.85% of Norway is Saudi Arabia. Well, what does that mean? That means Saudi Arabia is what percent less than Norway? And we always base it on 100%. So when you subtract 100% from this, you will get a 0.15 and you will get an 87. So it is an 87.15% decrease. That is how you can do that problem. If you go the other direction, you could say, what kind of an increase would it be? Well, I could go and do a whole lot of work, or I just divide 7.08 divided by 0.91. This is not the question that's being asked, but it's a good one because my tests are never the exact question that was being asked. 7.08 divided by 0.91. Let's see what I end up with. Ooh, I end up with the number 7.78. And then a bunch of decimals, 0, 2, 1, 9, 7, 8, da, 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 da. Okay. So if I look at that, then I would say, wow, that's pretty impressive. So that means that Saudi Arabia times 7.78 equals Norway. That means Norway is 778% of Saudi Arabia, right? And that means it's 678% more than Saudi Arabia. And that's the sheet that we did in class where I said, find your factor, it's a percent, and then turn it into a percent more or less than. So one direction, it's 678% more than. The other direction, it's 87.15% less than. There we go. Clearing all the drawings. 25. Let's see here. Last one says 25. The crust on a pumpkin pie is 25% of the pie. By what percent should it be reduced to make it constitute 20% of the pie? All right, well, don't fight it, just write it. Let's take a look. Don't fight it, just write it. Love it. Pumpkin pie was, I don't know, I always get the Costco one because it's like $6 and it's like 400 pounds of pie. All right, crust is 25% of the pie. So crust is 25% of the pie. There we go. By what percent should it be reduced to make it 20% of the pie? Okay, well, I want it to be 20% of the pie. I want the crust to be 20% of the pie. And what that means is I have to multiply by something here, right? I have to multiply here. And what do I multiply by to get that to work out? So 25% times I don't know what has to equal 20%. Okay. If you want to, solve for your missing piece. It's 20% divided by 25%, which turns out to be what? Well, the percentages go away because we're dividing. I get 20 over 25, which is really 4 over 5. So 4 over 5, this is 4/5 what I need. 4/5 becomes 0.80, which becomes 80% of, which becomes a 20% decrease. And this just follows that sheet we did in class. So find your factor. What do I multiply by? Turn that into a percent and then read your percent. If you're going with an increase or a decrease, always compare it to 100%. So I'm always thinking of 100%. You're like, that's 100% awesome, but I only have 80. Ah, you had a 20% decrease then. That is correct. Now, if you want to check yourself, you can take the 25% and take 20% decrease. So you can do it the very, very, very long way that I know some of you still want to do. Take 20% of this, 20% of 25% becomes, when you multiply, 5%. And that is the amount of decrease. So take your 25% and decrease by 5%, and you end up with 20%, which is what we wanted. Okay. There it is. There you go. 20% decrease. Nice. Gotta love it. What's the other way? Oh, if I was doing the shortcut way, yeah, you're right. If you want to check yourself, some of you, I'm sure, are like, Scott, don't make me do the long way. You're right. Take your 25%, multiply by the factor, which is 80%, because you have 80% left. And 25% times 0.8 turns out, when you multiply it, to be exactly 20%. So you can get there in one of two ways. The Fallström's freaking fast way, or the Dr. Phil way. Right? It's not wrong. It's just long. There we go. I love it. So again, that's why that worksheet was there in class, that activity brought to you by me, because I think that's one of the pieces that students do definitely tend to struggle with. I know it's a challenge. Yeah. All right. If you have other questions, let me know. Otherwise, off you go.